The word polygon means many angles. So poly means many, gon means angles. So in this particular shape you've got many angles. It's got 5 angles, and you would say a polygon it's just a way of defining shapes with lots of different angles in them. For example, this one has got 1, 2, 3, 4, 5, 6, 7. This is called a heptagon. So you've got the different sorts of parts, the different prefixes of these words, and it tells you how many angles it has. It also tells you how many sides it has. But this is actually how many angles. So heptagon comes from the Greek for 7. Interestingly, most of the other ones come from Latin. This is one of the Greek ones. So with 5, you would call this a pentagon. Then 6 is hexagon. So you've got 5 angles would have the prefix pent. 6 has the prefix hex. 7 has the prefix hept. 8 is oct. And 9 is non. And 10 is dec. Now this one here, dodecagon, that actually means, the do means 2, the dec means 10, and this overall means 12. So this must have 12 angles in it. But I've leapt ahead here a little bit. What we're doing here is the interior angles. So if we're looking at a regular polygon, that means that all of the angles inside the shape are equal. They're all the same. And if we know that inside any shape you can make it up with triangles, you could cut this into triangles like this. If you go from one corner out to the other corners, that should have met that one, but you can sort of see what I'm saying. Each one of these has got 180 degrees in it from what I mentioned earlier. And by adding these together, you can find out the total interior angle of any polygon. Notice inside a 5-sided shape there were 3 triangles. I'm going to do that in a different colour. Let's do yellow. So in yellow I'm going to say how many triangles there are in each shape. In a pentagon there were 3. In a hexagon there are 4. In a heptagon there are 5. In an octagon there are 6. In a nonagon you can see it's going to be 7, decagon 8. Every time it's just 2 fewer triangles than the number of angles. So we can generate a formula here to work out how many triangles there are in an n-sided shape. So if you had an n-sided shape, let's say that the n was 100, how many triangles would you be able to fit into that? It would be 98, or n minus 2. So n minus 2 triangles fit inside an n-sided shape. So if I said that my shape had 12 sides, how could I work out each interior angle? Well, first of all, what's the total interior angle? If I added all of them together, what would it be? If I have 12 sides, then if I take away 2 from that, that tells me how many triangles there are. So there are 10 triangles, and each triangle has 180 degrees. So in total, this must have 1,800 degrees. So if I added all the interior angles together, it would be 1,800 degrees. And then by dividing this now by 12, I can find out how many degrees there would be in each of the interior angles. So, just reaching for my calculator here, I really should be doing this, but I can't do this in my head very quickly. Divided by 12, what's that? 150, okay. So I'm going to do all my interior angles divided by the number of angles that there are, and that tells me each one is 150 degrees. Oops, 150 degrees. So that is the interior angle of a regular dodecagon. It has to be regular because otherwise I couldn't tell you what each one was. By dividing it by 12, I'm suggesting that they are all equal. Now you may notice here, actually, there's oct here and dec here. It sort of looks a bit like October and December, and that is where they come from. October meaning the 8th month, December meaning the 10th month. But October's not the 8th month, it's the 10th month. And December's not the 10th month, it's the 12th month. But interestingly, the two guys got in the way there. Julius Caesar put July in there, and Augustus he put August in there, and they screwed up the system. So they kept the names of the months, but they made it two months later, which is quite interesting, I think. Anyway, let's move on. So in our second example, it says find the sum of the interior angles. That means the total interior angle. So we don't have to divide it then by the number of angles. We just have to find the total. So if we look at the hept bit, that means 7 angles. If there are 7 angles, then there would be 5 triangles. Each triangle has 180 degrees inside it. So then 5 times that is that divided by 2 times 10, which is 900 degrees. And then 900 degrees is our answer, because we're trying to find the sum of the interior angle. So that is that's the final answer. Okay, let's have a look at the third works example here. So this octagon has three different shaded triangles here, and it's asking us to draw in any lines of symmetry. So that means if I to lay a mirror along, let's say this bit here, it would be the same on both sides, and it is. But if I laid a mirror along this axis, it would not be the same on both sides, because you've got a shaded side here, but it's not shaded that side. So the one I've just drawn doesn't work. The first one I drew here is the only line of symmetry. And the final part of this video, we have to shade in an extra triangle so that it has rotational symmetry. And you may be able to spot that if I didn't shade any of the triangles, if I rotated it, how many times would it be the same in 360 degrees? It's just once. So we need to make it have a rotational symmetry of more than one, and I can do that by shading this one in. In that case, it would give me a total of 4. Okay, now have a go at the exercises.